So we left off last time to talk about 2D arrays. These 2D arrays make sense, but they aren't exactly straightforward at first glance. So let's see. So let's suppose we've got some data type t. So t could be int, for example. And we can make an array of 6t, calling it n. So we're declaring n to be an array of 6t. We know how to do that. And so that you can sort of think of the type of n as t of 6. Okay? So t6 is effectively a data type. Okay, so again, t could be int, could be char, could be float, any type we know about. But if it's a data type, then we can have an array of it. Okay? Now here's where things look a bit strange at first glance. So if I want an array of 7 of this t of 6, I would write it out this way. Okay? And so this isn't exactly how you'd expect to do it. So it's an array of 7t of 6, so the 7 actually goes here. It's the array index closest to m. And the way you think about this is you can think of these, array index is an operator. And the precedence of these operators is you apply the one first that's closest to the variable name. So in this case, the variable name is m. Okay? So m of I is something of type t of 6. Okay? So each of these m of I is an array of 6 t's. And then m of ij is, you take that one step further, and this is something of type t. Okay, this makes sense to everybody? So this is sort of a general rule in C, is the way you try to figure out what these definitions mean, is that you start off with the variable name, and then following the rules of operator precedence, choose the operator who has the most precedence, which is closest to the variable name, and then proceed outwards. Okay. So here's a simple program. We're going to first initialize a 2D array. So the array is m. It's got 3 rows and 4 columns. So the 2 for loops initialize this array. Then we're going to call this routine print matrix. And print matrix, we're passing it m and also the bounds on the array, and it's going to print out the matrix. Now the way we want to print it is what's known as row major order. We're printing this out by the rows of the array. Okay? And again, the way we're thinking of this array, this array is 3 rows by 4 columns. So you can think of it as a matrix that's 3 by 4, or you can think of it as a 3-dimensional array where each component of this an array with 3 elements, where each of these elements is an array of 4 elements. Okay? So each component of this larger array is this row vector. First one is 0, 1, 2, 3. The next one is 4, 5, 6, 7, and so forth. Okay? So here's the print matrix routine. Okay? So we're passing it. There we go again. We're passing it the reference to the array, but we also have to tell it, again, so last time, is that we can give it the dimensions of the array here, but that doesn't really mean anything to it. We've got to tell it as separate arguments what the dimensions of this are. Okay? So then, having done that, we can go and then print out each element of the array. Now, an alternative way of doing this is, well, we saw before that we can print out a single dimension array without giving in the argument list what the bound is. Now we're sort of doing that here. Okay, except as a single dimension array, this is an array of int in C. Okay, so it's an array of row vectors, each of size nc. So we can leave off the dimension for this as treating it as a one-dimensional array, but we have to tell it what the type is of each of the elements, and each of the elements is an int in C. Okay? if we leave off more than that, this will become clearer when we see how these are exactly laid out in storage. If we leave off more than this, then the C compiler doesn't really know how big each row is. It can't figure out how to access the elements. Okay, so doing it this way is exactly the same thing as doing as we saw in the previous slide. Question?
Now, because it used the NC variable, does that mean it is required to be declared after the other two parameters?
It must know what NC is. So in this case, you're right. It must be after the other two parameters. So you have to declare. You got to tell it what NC is before you know what to do with it. Okay. Now, here's another way of doing it. So here we are explicitly taking advantage of the fact that this is an array of row vectors. So in this version of print matrix, I have a single for loop that calls print array that prints out a single row vector. Okay, so I'm printing out each of the 3 row vectors one at a time by calling print array. Okay, then print array is down here, and I'm printing out each element in the row vector, and then printing out the new one. Okay, does that make sense to everyone? Okay. Now, the way it's actually laid out in memory looks like this. So it's actually laid out in this row major order. So the rightmost subscript is varied first. So we have m of 0, 0, m of 0, 1, m of 0, 2. Okay, then we've got m1, 0, m1, 1, m1, 2, and so forth. Okay? And we're going to see a lot more about how this layout works a little bit later on when we see how data is actually represented. But just one brief aside. Can anybody see what's wrong with this slide? Why the exhortation, don't do this?
You're returning a pointer to something you declared locally?
We're returning a pointer to something that declared locally, and the problem is when we return from this, since it was declared locally, what the pointer points to won't exist anymore. Okay, does everybody see that? So A is essentially a pointer to this array of dimension 2. And while we're inside of this routine getArray, okay, it makes perfect sense to refer to A, but the lifetime of the array A is only as long as we're inside of this routine. As soon as we return from it, it's gone. Okay? So C has no problem letting you do this. Again, maybe you can find a reason for why you want to do this. You don't really know what that is, but strictly speaking, this isn't going to work. Yeah?
Even though it's a bad idea, if you were to do it syntactically correctly, wouldn't you do return $A because you're trying to return the address?
Well, we might return $A of 0. But A all by itself refers to is the reference to the entire array. Okay? So that's a good point. The name of the array is essentially the same as the address of the first element. So same as $A of 0. Okay? Now, so all objects declared in functions, such as arguments and local variables, are allocated on the stack. There'll be one exception to this coming up, but for the most part this is true. And they're deallocated after the function returns. Okay, so never return or use an address of any of these things after the function call. C will let you do it, but C lets you do all sorts of things, which you shouldn't do. Okay? Okay. Now, let's take a quick look at global variables. Okay. So, in this function, okay, the scope of M is global. It's declared outside of the function. So what this means is it can be used by anybody. Okay, at least anybody in this file. Okay. So it's always going to exist. Okay, now we can sort of get some notion that this really is sort of different from the local variables. So what we're doing here, inside of main, we're printing out the address of M, and we're also printing out the address of a local variable row in this routine. Okay, so M is not allocated on the stack, but row is. And you notice that the address of M is considerably different from the address of something on the stack. So we'll get into this a lot more later on, but the point of this is they are allocated in totally different parts of memory. Okay, they've got no relation to each other whatsoever in terms of where they are. Okay? But another thing here is that unlike local variables, global variables are actually initialized. They're initialized by the system. You don't have to initialize them. Implicitly, if you don't do anything else with them, they're given an initial value of 0. Okay, so it makes sense to print out the first element of m, even though we didn't initialize it, because it's going to be a 0. Okay? Okay, now one last slide in this file. We've seen printf, and we've used that a number of times. So the inverse of printf is scanf. This is for reading input from the keyboard. And it works sort of like printf. The first argument is a format string, which tells you how to interpret, in this case, the input. Okay? And what we want to do here is to read in 2 decimal values from the input and put them into these integer variables I and j. Okay? Now, can anybody tell me why we've got to pass the addresses of I and j to scanf rather than just putting I and j there?
If you don't give it the address, you will make a local copy within scanf of the value that's at I and j, and then you will no longer be able to change the original I and j back in the main function.
That's right. Remember that parameters are passed by value, as we saw last time. And if I just pass the value here, we're going to have the value of I and j inside of scanf, but we can't get it out of it. Okay, so what we really want to do is have scanf get these things, put them in the locations referred to by the pointers to I and j, so they end up actually in the I and j up here. Okay? All right. So now I've got to do the tricky operation of